Good afternoon, everyone, my dear students and friends also, right?
Good afternoon.
Good afternoon, sir.
Good
Very
afternoon.
much.
Good afternoon, sir.
Good afternoon. Thank you very much for joining this lecture second on basic electrical technology, right? Now, yesterday we had the introductory lecture, and after the lecture, the questions which you asked, I was very happy with that. Very happy because the questions and answers are the way to broaden the frontiers of knowledge. Unless people are inquisitive, we cannot broaden the frontiers of knowledge. We cannot build the intellectual capital. So, therefore, today, in line with the objectives of this session, I will raise some questions, right? You can see the outcome expected from this session is that once you are done with this session, you should be able to recall the basic elements of a DC network. DC means direct current, in which direct current means what? The current is not changing with respect to time. That is important to understand. What do we mean by DC? Direct current, of course, that is the full form, but the meaning is current is not changing with respect to time. Please understand that. Okay. And we will also get into circuit reduction techniques. Okay. Let us quickly recall. Now, the questions we will be addressing in this session are the following. Questions to be addressed. What are the basic circuit elements of a DC network? Okay. Second question, how we can meaningfully solve relevant problems pertaining to a DC network. Now, the approach which I will be taking is based on fundamentals of physics. Okay, what are the approach I will be taking? KCL, KVL, and fundamental properties of the circuit elements, and this will set the tone for our future discussion. Okay, so can you quickly answer the first question which is written on the left pane of my screen?
Battery.
Very good. Battery, what else?
Resistance.
Louder please, my dear friend.
Resistance.
Very good.
Connecting wires.
Conductors, very good.
The ammeter, voltmeter.
The measuring device requires.
Meters.
Switch.
Ammeter, voltmeter.
Very good. Ammeters, voltmeter. What else, dear?
Switch.
Capacitors.
Rheostat.
Wire.
Okay. Okay.
Inductors.
Very good. Very good. Very good. Thank you very much. Thank you very much. Anything else?
Key.
Hmm?
Switch.
Okay. Switch, of course, is needed.
The wire.
Conducting wires. That's done.
The rheostat.
Rheostat. Very good. They belong to the category of resistance. Okay. Now I will summarize. Okay.
Transistor.
Transistor. Very good. But we will not be dealing with them right now. Why? Because transistor can itself be modeled in terms of these basic circuit elements. Okay, so again they come under two category: active, passive. Active and passive circuit element. Okay, we will not provide you the full list now. Okay, but for our interest in this context, this is our context. Okay, this is our context. In this context we will be giving you only some of the elements, like I have a voltage source. Okay, and a current source. Sorry, I should not write it here. Excuse me. Current source. Okay, and as far as the passive element, we will only consider R now. Okay, although you have L, you have C also. Okay, now what differentiates them? What?
Active elements are those that supply energy, and
Correct. Passive elements are those elements which
consume energy.
consume energy. Very good. Okay, passive and active, that difference is very clear, and even if it is not clear, it will become clear in course of time. Now if you read different literatures, okay, across domain, this term is something which will be used again and again in different domains. Now what differentiates both of them is very simple. If you have element, let us say an arbitrary circuit element, okay, and you know the V and you know I, right? You know V and you know I, and you are taking a convention that if I choose the convention that an element sinking power okay is considered to be positive, P is considered to be positive, an element sourcing that will be considered negative. This convention is known as passive sign convention. This is very important. Generally, we follow the passive sign convention. Okay. And any element which is sinking power is said to be passive, and any element which is sourcing power is said to be active. Okay. Why this is called passive sign convention? Because you are giving positive sign for power being synced. Okay. And you are giving negative sign for power being sourced. Okay. So if you see this, if I is positive, what are the four possibilities? Sorry. And if this is the case, what will be the value for P, sign of P? Negative, positive, positive, negative. So these are the four possible combinations. In this case, in case 1, my element is said to be active. In case 2, my element is said to be positive. In case 3, okay, if you allow me to write it, 1, 2, 3, 4. In this case, element is said to be active. Okay, this is passive sign convention. Is this much clear? Can we proceed ahead? Yes or no?
Yes, sir.
Why?
Yes,
Because
sir.
I am telling you, for every class there will be one formative assignment. Formative assignment means what? It is for your for checking your understanding. Okay. It's not that you assignment नहीं किया आप तो वो ऐसा हो जाएगा वैसा हो जाएगा, no. But as a mature person, if somebody takes admission into an engineering stream, he is expected to be mature, right? As a mature person, I expect all of you to attempt that. Okay. So this will help me to get a feedback of how a person is understanding or how the class is understanding. It will be on Microsoft Teams only. I will be posting the first quiz tomorrow, second on Thursday, and third on Friday. Is that okay? And it will be available for sufficient time. You just can check into it and answer those questions. Okay. So please, if you have any doubt, please ask me. Otherwise, I will know who has understand how much.
Excuse me, sir.
Yes, dear.
So please.
How is for the second? Because current increases in the direction. Sorry, field decreases in the direction of current. So we should be negative when the current is positive, and vice versa. But second
You are
and third
talking
should not be
about case
possible.
1 or case 2 or case 3 or case 4?
I'm
Case
saying
2.
case 2 and case 3 are not possible because
Slowly, dear, my dear friend, what's your name?
others.
Slowly, so that. Okay, so tell me, case 2. What you want to say? Case 2 and case 3 are not possible.
Yes, because potential decreases in the direction of current. So that's my doubt. How is it possible?
Okay. Case 2 and case 3, he is telling, let us say I have a resistor. Okay. The potential will be this. and current will be this. You agree with me or not?
Yes, sir.
Let us say the value of resistor is 2 kilo ohm, okay, and the value of current is 1 by 2 milliampere. Then what will be the value of the voltage? 2 kilo ohm into 1 by 2 milliampere gives me 2 volt. So I think I have demonstrated that case 2 is possible.
So 1 volt. I mean,
No, correct. You're correct. Thank you, dear. Thank you. It's 1 volt. But I have demonstrated that case 2 is possible. You agree with me or not? Yes or no?
yes.
Agreed? And
Yes.
now, what I can say, I can just flip it. Actually, if you see case 2 and 3 are not very different. Actually, they are same, ultimately from a power perspective. That's the convention I am talking about. Okay? Is that okay? Your doubt
Yes.
has been addressed?
Yes.
Okay, so we'll proceed to the next thing. Now, what is a voltage source? What is a current source? This will I will come to later. Okay, because some student might be. Let me add some pages. What is a voltage source, right? What is a voltage source? Can you give me some examples of voltage source? Battery. Okay. Some more examples.
Generator.
Yes. Generators.
Solar cell.
I beg to differ. Actually, it's a controversial thing. Some people call it a current source. Some people call it a voltage source. Okay, never mind. Okay, so what are the other examples? You can have many more. Okay, but I can give you more like super capacitors. Please understand, this is a new category, a recent category. Then you have pseudo, they can act as voltage source. Okay, but I will not confuse you with this. Okay, if you want to ask, you can ask me, but let it be there. Generators. Okay, DC generators more precisely, because right now we are talking about that. So a voltage source, let me define it, is a source of EMF, electromotive force. Okay, the source of electromotive force by dint of some inherent energy conversion, or I should say energy generation. Okay, energy storage mechanism. Okay, energy storage, energy conversion mechanism. Okay. Now, what is the mechanism in this case? It is electrochemical. Okay, it can be Faradaic or non-Faradaic. Okay, generators, what is the mechanism? The mechanism is motional EMF generation. as in DC generators. But how do I model it? At this point of time, it is more important for me, how do I model it? So it can be an ideal voltage source or a practical voltage source. Is my handwriting able to all of? Is it
Yes,
visible?
sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah.
Ever find any glitch in what I'm writing? You are not able to read. Please let me know. Okay. Now, if you see, what is important for us is the model of an voltage source. How do you model of a voltage source? And I must confess that I am presenting a super duper simplified model. Okay, it can be an ideal version or practical now, but it keeps the promise they deliver. Now, when I say the accuracy of a model depends upon how much information it is supposed to convey. Models for batteries can be very complicated. Not complicated because you want more information. You have to address all the phenomenons which you want to address. For our purpose, we will just talk about its ideal version and its practical version. So ideally,
Excuse me, sir.
yes, please.
Sir, there is a lot of problem of internet at my end. I am not able to hear clearly anything from the starting. So what can I do?
Okay, so if there is internet connectivity issue, what you can do, uh, do not worry because it is not in my hand or in your hand. You can try to fix it as much as possible. Okay, but you must be getting good internet connectivity at least at some point of time, right?
So yes, the classes are working since morning. My sister's class are also, so that's the problem.
Okay.
I'll watch the videos which you put on portal and can I ask the doubts later which you have already taught?
Sure. That I have told yesterday only. You have my number. All of you have my number. If you have still you do not have, please note it down. Okay.
Okay. Thank
You
you, sir.
can ask me doubt anytime. Okay. Okay.
Yes.
And okay. And I will respond to it. Do not worry. Okay. So ideal voltage source. Ideal voltage source, if you see, how do you represent it? One representation is this. Okay. Another representation is this. Practical voltage source. If you see the practical voltage source at our level, again at a preliminary level for DC phenomenon, and we are not much interested in exploring so many other phenomena. Okay, you can just add a source resistance to it. In this case, if you call the terminal 11 dash, V11 dash is equal to Vs. Some people call it the terminal voltage, okay, Vt. Okay. V11 dash is the terminal voltage, okay, and in this case V11 dash will be equal to what? To understand that, let us make one addition to our circuit. Imagine that this voltage source is supplying a current I to a load network. Why I'm calling it a network? It may be a simple resistance or it may be a combination of resistances. Okay, so my V11 dash will be equal to what? See, here it is Vs. Imagine that this is the reference point, so this will be 0. Okay, you basically we are interested in potential difference, we are not interested in potential, absolute potential. So assume this to be 0 volt, so this node will be at plus Vs, right? So and the current is flowing as I. So what will be the voltage drop through this resistance Rs? What will be the voltage drop if you have a
IRS.
Very good. IRS. And the polarity I have shown like this. Why? Because if a current I is flowing in this direction, it produces a potential difference V is equal to IR. Okay, with this polarity. Okay, so if this node is at Vs, so naturally what will be the potential of this node? It will be Vs minus IRS. Okay, so it will be Vs minus IRS. So this is the difference. Okay, the goodness of the goodness, or you can say whatever, the goodness of a voltage source may be evaluated in terms of what? RS, or the source resistance. Okay, for a good quality voltage source, RS should be as low as possible. Okay, and ideally you have seen only that its RS is 0. Now coming to current source. Ideal version Yes. Okay. So the current entering into the network, if you call it IN, will be equal to IS. Okay. Practical version. I network I network will be equal to B, sorry, I network will be equal to IS minus VN GS. What is GS? GS is the conductance of the current source, and GS is 1 upon RS. What is the unit of GS? MHO. Sorry, not MHO. Yeah, MHO only. MHO or this, or you can write this. All of them are acceptable. It is called Zeeman. This is called Zeeman. Okay, and written as SIEMEN. Okay, and this is called amateur or Zeeman. Okay, now the figure of merit GS is an important parameter for current source. Why? Why? Higher the GS, lower will be IN. Okay. Therefore, GS should tend to 0, or what we can say, RS should tend to infinity. Why? Because RS is equal to 1 upon GS. Is that clear? For an ideal current, GS equals 0. Okay. Is this much clear? Can I move ahead? Can I move
Yes,
ahead?
sir. Yes, sir.
Thank you. Am I being too slow?
No, sir.
Okay,
No, sir.
if I am ever being too slow, too fast, see, you have to give me the feedback. Sir, you are too slow, sir, you are too fast. Okay, because I am not even seeing your faces, my dear students. Because in an online class, once a teacher, not only me, any teacher, he sees the face of his students, he gets a feedback. How much the concept has gone, or is it slow, is it whatever. Okay, so you have to tell me. Okay, you have to be very active, more active even during the normal classes. Okay, now there is some concept known as source transformation, but you have to be very careful how and where you apply. In my past experience of teaching this course, many times the examinee, sorry, not examiner, the examinee applies it wrongly, and unfortunately he loses his marks. Okay, be careful. I will explain it very, very slowly so that you do not fall into the pits of this technique. Okay, the technique I will tell you, because I've talked of sources. Now it becomes relevant to talk of, if you have a practical current source, IS, is equal to, which is supplying energy on a load network. Let the two terminals be 1 dash. The voltage you can take as, let us say, Vn. Okay, and the current entering into it, In. Okay, now if I want to look at the same load network, and voltage should also be same, and the current should also be same, but I want to represent this part as a voltage source. So can I do it? Okay, can I do it? The answer is a resounding yes. Okay, so what I have to do, voltage source is this, okay. So what should be the value of, okay, value of this Vs. Okay, now Vs will be equal to what? Vs will be equal to Is into Rs, and this Rs remains the same. Okay, is that okay? And if I want to move from this side to this side, I can write Is is equal to Vs upon Rs. So this is a source transformation technique. What is the pitfall? What is the pitfall? Let me write it. Very dangerous pitfall. You lose the entire marks. Okay, the entire problem becomes wrong. And I was just talking to one of my relatives. She didn't understand this actually. She did a mistake in the J mains probably. JEE mains, I was discussing this. She wrongly applied and she lost marks actually. So please be careful in this. Okay. Pitfall is that, see, here if I ask you what is the current through this resistor, okay, I will take a problem, then it will become more easy for you to understand. Imagine I have a 2 milliampere current source with a source conductance of 0.1, yeah, 0.1 millisiemens, okay, and it is supplying energy to a load having 50 kilo ohm, right? 50 kilo ohm. Is that okay? Question is, find current in the branch AB. Okay, find current in the branch AB, and allow me to even call it I. This is the question. Now first I will solve it wrongly and then I will solve it correctly. Wrong approach. Wrong approach. I didn't teach this. I never used to teach this unless and until I saw my students faltering at this. Wrong approach is to milliampere point 1 millisiemens is equal to 10 kilo ohm. Okay. RL is equal to 50, and the answer you get is 2 milliampere upon 0.1 will be equal to how much? What is the value of this? Tell me. 20 volts, right? So answer you get is 20 upon 60 kilo ohm 1 by 3 milliampere. Okay. 0.33 milliampere. Is it correct answer? Yes or no? Is it correct answer? Yes or no? Nobody is saying a word. Why? You must have calculated.
Sir, I don't think it's the correct answer, sir.
What?
I don't think it's the correct answer, sir.
It's wrong. In fact, you can just see it's the wrong approach only. Right approach. This is 2 milliampere. This is how much? 10 kilo ohm. Why I'm saying that? Because 0.1 milli ohm conductance is equivalent to 10 kilo ohm resistance. These are the same thing of saying the same fact. Different ways of saying the same thing. Okay. So 10 kilo ohm. This is A, B, and this is RL. Now, what will be current through this? Tell me. There are different ways of doing it. I will give you a very quick answer. Later, of course, we will explain also. There are different ways of doing this problem. Very simple problem. You must have heard of current division rule. Even if you have not heard of it, please do not worry. I will be telling you this. Please do not worry. Okay. So I is equal to I 10 kilo ohm will be equal to 2 milliampere into 50 upon 50 plus 10, both being kilo ohm. They will get cancelled. So the answer is 10 by 6 milliampere. Okay, so the correct answer is this. But my intention here is not to solve a problem for you now. That will come at later stage. This will be 5 by 3 milliampere. 5 by 3 milliampere, and this will be what? 1 milliampere. And of course this is 2 milliampere. 2 milliampere. Is that clear? Now, what was wrong with this approach?
Sir, it was using it in series, the resistance.
What?
Uh, we calculated the resistance in series.
See, the problem is that if I change my question, okay, if I ask you find the current through RL, then this works. This approach works, but doesn't work for here. This. Can somebody provide me a commentary on this? What is wrong in this? I am not talking about, problem solving right now. Just tell me what is wrong with this, solving this by this. I will give you 1 minute to think of it and download the attendance in the meanwhile. Please think of it. Just, you do not have to worry about how the problem is being solved. What's wrong? Just look at it. Just look at it and tell me what was wrong with our approach when we tried to find out the solution in the way we've tried to find out. Anyone? Just say anything. See, nobody is going to judge you for this, whether you are right or
Sir, can I see the circuit diagram again?
is it not visible?
No, sir.
Why?
Uh,
You were
yeah,
downloading
now it's visible, sir.
downloading the list. We can see you downloading the list, not the
Oh,
circuit
oh,
diagram.
Yes,
you
sir.
can see everything. Okay, I'll just save it. Okay. Now you can see.
Yes,
Yes,
sir.
sir.
Provide me a commentary, an explanation. Doesn't matter. Okay. See, listen carefully, my dear friends. You need more time, or you want to say something?
So, I just want doubt, sir. You just said that if you had asked the question to find the current through RL, then
Yeah.
the one which we solved to which you wrote wrong approach would be correct.
Yes.
Okay.
The second approach can work for this question because we found voltage, but in parallel voltage is the same in both the branches.
Exactly. What's your name, my dear student?
Anushka.
Anushka. Very good. She has targeted the root of the problem actually. Very, very good. Very good. See, in the first question, I was interested in finding this current. So when I was interested in finding the current in a resistor, listen carefully, I am saying very slowly. When I am interested in finding the current in a resistor, I should not change the electrical parameters which were representing it. Okay, see, if I am interested to find current through a resistor, if the what is the current? If V is known, R is known, IR is VR upon R. This is the model. Mind you, my dear friends, that model means what? It is a representation. Let us say a particular celebrity is a model of a particular brand or a particular sub brand of a bigger corporate house, right? You cannot change the model and expect the same appeal from the consumers, okay? Because even different celebrity have their own brand equity, okay? Different personalities have their own brand equity. Getting my point? Okay? So this 2 milliampere current source is being converted into a voltage source. But when you are doing this, see, you are committing a blunder if you are using it to find the first thing. See, this is a B. What is the voltage across? Let us say it is 0 and it is VA. The voltage is VA, right? Now, what is the voltage across this element now? This is 0, of course. So this will be what? Plus 20, right? Now, what is the voltage across this element? VA minus 20 is the potential difference. You agree or not?
Yes, sir.
But originally, if you see the configuration of this resistor, the voltage across it is VA. Okay, now you have changed by making such transformation, you have changed. So the only caution you have to exercise is that do not change the electrical observables or electrical parameters associated with an element. You are interested in. Now, if you see this, if they are asking you this question, in this place also, the voltage is VA, here also the voltage is VA. So it's cool with this resistor if you use this approach, but it's not cool with this element. Is that clear? Is the pitfall clear to everyone? Is the
Yes,
pitfall
sir.
clear to everyone?
Yes, sir.
Okay. So how much time we are having now? How much time is left? Okay, we have a lot of time, it means. Okay. So now I will introduce you something else. Okay. Mathematics is okay. Anybody having any doubt in this till whatever we have taught?
Sir,
This.
the class was till 3:15 now.
Okay, so that was what I was asking. I was not able to see the time. Huh? So we will stop now. Okay.
Sir, if you don't mind, can you please explain it once more?
I will explain. See, that's what those who want to leave can leave, no problem. But I am there. I do not have a meeting now. Okay. I have a meeting now, but not now. Okay, I am available. So you want me to explain this?
Yes, sir.
Yes.
See, what is happening when the person is asking you find current in the branch AB? Okay, if I take this approach, I am changing the potential across this AB, right? Here the potential is VA minus VB. What is the potential across it? VAB is equal to VA minus VB, and because VB is grounded, you can take it at 0 volt. It is VA, right?
Yes.
Clear? But if you see this one, this is 0 volt. Okay, so naturally, what will be the potential here? 20 volts. Now, what is the potential across this? This is at VA, this is at 20. So this voltage is VA minus 20. So by introducing this transformation, you have changed the very voltage across it. Getting my point?
Yes, sir.
But for the second part, if somebody is telling you to find a current through RL, and if you are using this approach, you will get full marks. But the paper setters, they know where we have the tendency to make mistakes, where the examinee can make mistake. Therefore, they will not ask you, they will give you this, and they will not ask you the current through this. They will ask you the current through this one. Is that okay? Understood or
Yes,
not?
sir.
Anybody having any other
Yes,
doubt,
sir.
please feel free to ask.
So
Yes.
actually the problem was that we drew the wrong diagram.
Yeah, no, see, if somebody asks you this, you should not tamper, you should not spoil the electrical configuration of this resistor. Electrical configuration of a resistor includes only two things, V and I. The third thing you can get very easily. Okay. The third thing you can get very easily, to not tamper with the electrical definition of this resistor. By doing this transformation, it is perfectly legal if you want to find the current through RL, because see, nothing has changed for RL, but for this things have changed, the voltage has changed. Okay, clear? Do I need to explain again?
No, sir. Got it. Sir.
Got it?
Yes, sir.
Can
Sir,
we?
I have a question. Sir, where are the notes available for today's session?
See, actually the notes are. Have you explored the notes assignment section yesterday? The notes section, sorry.
No, sir.
Okay, so just go to your Microsoft Teams. Go to Teams. This is your team,
Okay.
right? With the calculator icon, right? Go to Files. Okay. The class material, the PPTs for all the lectures which was made combinedly by our team is available here. And the recorded lectures is available here. Just see. Yes, yesterday's recording is available here. Okay. Once this lecture gets finished, this will also get available. One thing I will request everyone that if I forget to start the recording, please remind me. I think today I have pressed it. Okay. You also must have got notification that this meeting is getting recorded.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
If
sir.
not
Yes, sir.
get, I will. It will
Yes.
be very kind of you. You
Yes,
can
sir.
remind me. Okay. Anything else?
Okay, sir.
Sir,
Anything? Yes.
so please explain me the passive convention again.
Very good. Passive sign convention. I will explain it again. What is passive sign convention? It says that if P is is less than 0, sorry. If P is greater than 0 and if P is less than 0. What can be the two cases? Any element may be acting either as source or as sink or load, right?
Yes, sir.
So if P is greater than 0, then you have to choose whether the element is passive or not. Okay.
So P is power.
Yes, P is power, and power in its most elementary way is V into I, and for DC networks you can write P is equal to V into I. Okay, it says that if P is greater than 0, element is passive. If it is less than 0, element is active. And what is the sign convention? This is your element, suppose. Okay, for passive sign convention we take this positive voltage is taken if this terminal is at higher potential, and positive current is taken if a positive current is entering into this. So this is your passive sign convention. Active sign convention, how do you draw it? This is active sign convention. Okay, is that clear? What is passive sign convention? What is active sign convention?
Yes, sir.
Yes or no?
Yes, sir.
Anybody saying no?
Sir, can you explain source transformation again?
Yeah, sure. Very good question. Source transformation technique. Imagine you have a current source of this active current element or the actual ideal version current source value is, and a source resistance Rs equal to 1 upon Gs. Okay, and something is connected across the load. Okay, want everything in terms of a voltage source what I can do, I can simply represent it like this. But you can see by introducing this, you have got an extra node here. Okay, here we had only two nodes if you look from here, A and B, but now you have an extra node X. Okay, so source transformation says that Is is equal to Vs upon Rs and Vs is equal to Is into Rs, or Is upon Gs or Gs Rs. Is that okay? This is the source transformation technique. Okay, the diagram you have to remember properly, and please be mindful of this, that there is an extra node being introduced.
Sir,
Yes,
GSVS होना चाहिए.
क्या?
IS is equal to GSVS.
Correct. Very good. Wonderful. Thank you, dear. So grateful to you. Thank you. Okay. Anything else? You understood source transformation, the person who asked me source transformation.
Yes, sir.
And here, a node is being lost. Okay. If you move from this side to this side, one node is being lost, and if you move from this side to this side, an extra node is being introduced. Any other doubt?
No, sir. Thank you.
Welcome. Anybody else having any other doubt?
Sir, can you please go back to that pitfall slide?
Yes, tell me. This side actually. So the pitfall, if you ask me, be careful not to tamper with the electrical characteristics of interest. What we did here, this resistor's electrical characteristics of interest were V across this and current flowing through this. We tempered it. Okay, the voltage level shifted, changed. Okay, so do not be in too much hurry. Okay, solve every problem on its own merit. Okay, anybody else having any other doubt? Anybody having any other doubt?
Sir,
Yes.
sir, what are some examples for current source?
Current source, solar current. Okay, I will write example.
What would be the main difference between current and voltage sources?
Solar PV panels. Main difference. Very good. Wonderful question. Voltage source. Current source. If I draw the characteristics, IV characteristics, voltage is constant. This is ideal voltage source. If I draw the IV characteristic of an ideal current source, ideal current source. Practically, what will happen? Practically, if you see what will happen, it will have some slope. Okay, as you change the voltage, what will happen? Practically, if you see, there will be some drooping characteristics. Okay. Or I will flip it for your understanding. I will flip it. This quadrant. V I. Sorry, it has to be a straight line. Okay, so this is ideal voltage source. Practically, if you see, it will be having a slope, right? As current increases, the voltage, terminal voltage decreases. Similarly, here also it will decrease. Okay, examples of current source: solar PV panels. What else? Transconductance amplifiers. Or you can say simply MOSFET. Okay, or sorry, BJT also you can say. But one thing I will tell you, I hope all of you are listening. Because we can convert one from the one side to other side, actually electrical characterization of a source of energy, be it in terms of voltage source and current source, is based upon modeling. So it depends upon what parameter of interest you want. Any other doubt?
Which source
No, sir.
is objectively better, voltage source or
What?
current source?
Again, I told you that these are models. Okay, these are models. We are studying electrical circuit models. Actually, you have a whole range of devices, energy storage devices. You have flywheels, you have solar cells. So it depends upon the application you want. You have fuel cells, okay, you have MHDs, so many other things are there. Anything else? Okay, so you are done with your doubts? Yeah.
The source transformation कहाँ apply होगा?
सोर्स ट्रांसफॉर्मेशन का एप्लीकेशन होता है बेटे सर्किट सिंप्लीफिकेशन में. यहाँ भी सर्किट मुझे सिंप्लीफाई करना है ना. मान लो मैंने आपको ये प्रॉब्लम दिया, अगर मुझे RL के थ्रू चाहिए करंट, है ना, तो मैं इसको सिंप्लीफाई कर दूंगा, मुझे एक लाइन में मिल जाता है। अभी तो यहाँ पे आपको लग रहा होगा कि ज़रूरत ही क्या है। एक्चुअली सोर्स ट्रांसफॉर्मेशन इज यूज्ड फॉर simplifying a network. Again, it depends upon a case-to-case basis. Anything else? Okay. So let us call it a day now. Anybody else having any other doubt can ask me. Otherwise, I am stopping the recording. Okay. Thank you very much. Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Always welcome.
Thank you, sir.
Welcome. Welcome.
Thank you, sir.
Welcome.